Now let's talk about frequency distribution. Frequency distribution is a table that shows classes or intervals of data entries with a count of the number of entries in each class. The frequency f of a class is the number of data entries in the class. In the given frequency distribution at the right, there are 6 classes. So 1, 2, 3, 4, 5, and 6. The frequencies for each of the 6 classes are 5, 8, 6, 8, 5, and 4. Next, we have this what we call lower class limit. The lower class limit is the least number that can belong to the class. So in the given frequency at the right, the lower class limits are 1, 6, 11, 16, 21, and 26. Next, we have this what we call upper class limit. The upper class limit is the greatest number that can belong to the class. So in the given frequency distribution table at the right, the upper class limits are 5, 10, 15, 20, 25, and 30. Again, the lower class limits are 1, 6, 11, 16, 21, and 26. And the upper class limits are 5, 10, 15, 20, 25, and 30. Now let's talk about the class width. The class width is the distance between the lower limits of consecutive classes or the upper limits of consecutive classes. So for the lower limits, so the consecutive classes are 1 and 6. So 6 minus 1 is 5. So the class width is 5. For the upper limits, that is 10 and 5 are the one of consecutive classes. So 10 minus 5 is 5. So 5 is the class width. So you can either use the lower limits or the upper limits for finding the class width. Next is the range. Range is the difference between the maximum and minimum data entries. So suppose the maximum data entry is 29 and the minimum data entry is 1. So just subtract 29 and 1. That is 29 minus 1 is 28. So the range is 28. Now let's construct the frequency distribution table. So let's follow the following steps. So first one, decide the number of classes to include in the frequency distribution. So the number of classes should be between 5 and 20. Second step, find the class width. So determine the range of the data divided by the range of the number of classes and round up to the next convenient number. Third step, find the class limits. So you can use the minimum data entry as the lower limit of the first class. Step number 4, make a tally mark for each data entry in the row of the appropriate class. And last one, count the tally marks to find the total frequency F for each class. So let's have this example number 1. The data set lists the prices in dollars of 30 portable global positioning system navigators. Construct a frequency distribution that has 7 classes. So step number 1, decide the number of classes. So stated in the problem, the number of classes is 7. Second step, find the class width. So the class width, the formula that is range over the number of classes. So meaning range divided by 7. So range is equal to the maximum data entry minus the minimum data entry. So the maximum data entry here is 340 and the minimum data entry is 65. So that is 340 minus 65 is 275. So the range is 275 and the number of classes is 7, meaning we have 7 rows. So to find the class width, that is just 275 divided by 7. So this is approximately 39.29. So take note, we're going to round up. So round up, we're going to add 1 to 39. Okay, so 39 plus 1 is 40. So the class width is 40. Now let's construct the frequency distribution table. So again, remember that the maximum data entry is 340 and the minimum data entry is 65 and the class width is 40. And the number of classes stated in the problem is 7. So meaning we have 7 rows. 1, 2, 3, 4, 5, 6, and 7. Okay. Now let's start. We're going to start with the least or the minimum data entry, which is 65. So 65 plus 40, that is 105. We're going to write it here on the second, going down. 105 plus 40, that is 145. Again, plus 40, this is 185. Plus 40, this is 225. Plus 40, this is 265. And plus 40, this is 305. Now, 65 to 104. Next to 104 is 105. 105 to 144. 145 to 184. That is next is 185. So 185 to 224. Now 225 to 264. 265 to 304. And 304 plus 40 is 344. Okay, next is the tally. Now let's make the tally. So make a tally mark for each data entry in the appropriate class. So 128, that is between 105 and 144. 100, that is between 65 and 104. 180, that is between 145 and 184. 150, that is between 145 and 184. So just continue. 200, 90, 340, that is between 305 and 344. 105, 85, 270, 200, this is between 185 and 224. 65, 230, this is between 225 and 264. 150, 150, 120, 130, 80, 230, 200, 110, 126, 170, 132, 140, 112, 90, 340, 170, and 190. That is between 185 to 224. Next is the frequency. So for the frequency, we're just going to count the tally. So here we have 6, we have 9, here we have 6, we have 4, 2, 1, and 2. So the classes, we have 1, 2, 3, 4, 5, 6, and 7. And the frequencies for each classes are 6, 9, 6, 4, 2, 1, and 2. Okay, next is the midpoint. So the midpoint, and this is sometimes called as the class mark. So the midpoint of the class is the sum of the lower and the upper limits divided by 2. So again, we have now the classes. Now the frequency, 6, 9, 6, 4, 2, 1, 2. Now add the frequencies. So the sum is equal to the number of data entries. So we have 30 data entries in the problem. So it must tally to the number of data entries in the problem. Now how are we going to find the midpoint? So the midpoint again, that is the sum of the lower limit and the upper limit divided by 2. So the upper limit for the first class is 65, the lower limit. Now plus the upper limit is 104. Now just divide it by 2 to find the midpoint. So that is 65 plus 104 divided by 2. So we have 84.5. Now, once we already have the first midpoint of the first class, we're just going to add 40 to 84.5. So 40 is our class width. So we're just going to add 40 to 84.5. So that is plus 40. So this is 124.5. So plus 40. So this is 164.5. Plus 40, this is 204.5. Plus 40, this is 244.5. Plus 40, this is 284.5. And plus 40, we have 324.5. Now, let's talk about relative frequency. The relative frequency is the portion or percentage of the data that falls in the class. To find the relative frequency of the class, we're just going to divide the frequency f by the total number of sample size n. So this n is actually the summation of the frequency. So the summation of frequency in our example is 30. So we're going to divide the frequency of a class by the summation or by n. So our n is 30. So let's have this. So the classes again, we're going to use the same example, the frequencies. Now the midpoints, so we have 84.5 up to 324.5. So to find the relative frequency, so we have here 6 by the frequency for the first class. We have 6 divided by 30. This is our n. So 6 divided by 30, so that is 0.2. So let's write here 0.2. Next is 9 divided by 30. So 9 divided by 30, so that is 0.3. Next, 6 divided by 30 again, so that this is 0.2. 4 divided by 30, this is 0.13. So just round off to 2 decimal places. Next, we have 2 divided by 30. So this is 0.07. Next, 1 divided by 30, we have 0.03. And 2 divided by 30, this is 0.07. Now, when we add this, the relative frequency, the summation of the relative frequency, this must be equal to 1. 0.2 plus 0.3 plus 0.2 plus 0.13 plus 0.07 plus 0.03 plus 0.07. So we have 1. So the total of the relative frequency must be equal to 1. That is equivalent to 100%. Let's talk about the cumulative frequency. So the cumulative frequency is the sum of the frequencies of the class and all previous classes. So the cumulative frequency of the last class is equal to the sample size n. So let's have the following. So again, so we have the classes, the frequency, the midpoint, the relative frequency. Now last here is the cumulative frequency. So the cumulative frequency, again, is the sum of the frequencies of the class and all previous classes. So take note here that we're going to start with the lowest or the minimum data entry. So the minimum data entry is 65. So we're going to start with the frequency of this entry. So that is 6. Now 6 plus 9 is 15. 15 plus 6 is 21. So 21 plus 4 is 25. 25 plus 2 is 27. 27 plus 1 is 28. And 28 plus 2 is 30. Take note, the cumulative frequency of the last class, this, is equal to the sample size n, or the summation of the frequency. Thank you.